So we have next question here. A particle of mass m kgs. A particle of mass m kgs lies at rest on a rough horizontal surface. A force of magnitude 1 by 5 mg is applied to the particle at an angle theta to the horizontal. Given that the particle remains at rest, show that mu is greater than or equal to cos theta by 5 plus sin theta. So this time we have to take a horizontal surface, horizontal rough surface, and let's say this is our block. So what are the forces acting on this? Okay, so downward force is how much? Downward force will be m into g. Upward reaction, let's call it as r. A force of magnitude 1 by 5 mg is applied to the particle theta to the horizontal. Okay, so is it pushing or pulling? That has not been told to us. So let's take it as being pulled. So this is mg by 5 or 1 by 5 mg. Okay.
Yes.
Mg by 5, this is the force, and this is acting at an angle theta here. So given that the particle remains at rest, we have to find the relation for mu. Okay. So friction will be maximum, no? Maximum friction is limiting friction, and that limiting friction is mu times r. This is the maximum friction that any surface can provide. So let's calculate for maximum value of friction, and then we will write it in this format. Okay. So again we have to start with a vertical component. Vertical component, r is acting upwards, mg is downwards, and then mg by 5 component of this vertical component is acting upwards, that is sin theta. This total should be equal to 0. I get the value of r. On the other side, mg I can take common, I'll be left with 1. This becomes minus sin theta by 5, correct?
Yes.
Then horizontal components I need to take. So we get mg by 5 into cos theta acting in forward direction minus mu r, this is acting in backward direction. So here we need to substitute the value of r. Substitute the value of r here. So mg by 5 cos theta, so this should be equal to 0, of course. Mg by 5 cos theta minus mu is not known, r is mg into 1 minus sin theta by 5. Now we are interested in finding mu, so keep mu on one side, send everything to the other side. So mu mg 1 minus sin theta, we have sent it to the left side. Right side we will have mg by 5 into cos theta. So mg and mg will cancel out, and mu will be equal to cos theta by 5, and we need to take reciprocal of this, right? So in order to take reciprocal, first let us apply LCM here. Let's apply LCM here. So we get 5 here. So we get 5 by 5 minus sin theta. So 5 and 5 will cancel. So mu equals cos theta by 5 minus sin theta. Okay. So this is for maximum friction. This is for maximum friction. Friction can be less than that also, no?
Yes.
So friction can be less than that also, and that's the reason we will get here friction has to be, the mu value has to be greater than or equal to this. Mu value has to be greater than or equal to this. If mu value is less than this, the object will start sliding. Correct?
Yes.
If mu value is less than that, object will start sliding. And in the question we have been given that it is at rest. Hence, this is, the mu value has to be greater than this. Hence proved. Let's see what we have next.